Yeah, moving on to the next one, the scope of physics. What is scope of physics? It is just like very single area, single domain. Is it? No. It has wide range of scope in physics. In physics part, if you are saying if you are going to measure any mass, any length value or time value, it has wide range. So its scope is also like wide range. And here the scope of physics is very wide range. If you are going to measure the mass from the physics part, we can able to measure up to 10 so far 10 to the power minus 30 kg for electron. Electron is very tiny, right, which can measure up, that can have the weight of 10 power minus 30 kilogram, whereas for the universe of mass it has 10 to the power 55 kilogram. So it has a wide range, right? We can able to measure between these two ranges, right? And we move on to length, the wide range of length. Even length also has a wide range. So 10 to the power minus 14 meter is the size of the nucleus. Size of the nucleus. So size of the nucleus is around femtometer range, right? So 10 to the power minus 15 is femto. Here I wrote 10 to the power minus 14 meter. And 10 to the power 26 the largest, the size of the universe. Size of the universe in the order of 10 to the power 26 meters. So between these range also is wide range, right? And in terms of time, it is also has wide range of time. So listen here, 10 to the power minus 22 seconds, that light cross the nuclear distance. Think about 10 to the power minus 22 seconds. See, this is 1 second, but they are given as point followed with 21 zeros and then 1, right? That gives 10 to the power minus 22 seconds. So that much level the light can travel that nuclear, right? So that cross the nuclear distance. And 10 to the power 18 seconds, that is a life of a sun, right? Life of the sun. So we have the wide range of mass, length and time. So the scope of physics also has wide range. And moving on to branches of physics, branches. And in physics part, only there are two major components we have, microscopic and macroscopic. Microscopic means a smaller size or tiny size particles we are going to deal with, and macroscopic particles in the sense the particle size is much greater when come. And here the branches of physics is categorized into two ways. One is microscopic, another one is macroscopic. Microscopic means we are deal with atoms, molecules and nuclei, whereas macroscopic means, as you all studied the laws of motion and gravitational laws, right? These are all under belongs to classical mechanics. So we are studying or observing the object in bigger in size. And optics, thermodynamics, yes, optics also we are deal with the lens part, right, along with light. And thermodynamics, heat, energy, entropy, everything is covered under in macroscopic. And there is a new one right now, mesoscopic. What is called mesoscopic? So this is very tiny size, which is much bigger in size. What is called mesoscopic? Mesoscopic is intermediate between microscopic and macroscopic. Mesoscopic means it is an intermediate between microscopic and macroscopic that deals with around 10 to 100 atoms or molecules. That is called mesoscopic. And what are the main subdisciplines in physics part? Majorly, we will have these categories, and we are going to study in later in plus grade 11 and grade 12 also. Mechanics. In 11th standard, we are deal with maximum mechanics, and mechanics is a deal about, as you know very well, right? Yes, and deals with the object which is in bigger in size. And optics, again lens, light, everything we are covered under this optics area. Thermodynamics, so full and fully we are going to study about heat, energy, entropy, yes, change in energy, that and all studied in thermodynamics part. And electrodynamics, as you know very well, electric field along with magnetic field, that will gives about electrodynamics. You all studied in lower classes magnetism, electricity, yes, yes. And this is one somehow different for you, quantum mechanics. Quantum mechanics is deal with microscopic particles like atoms, molecules, and I can give one small differentiation between these quantum mechanics and classical mechanics. So far you studied the classical mechanics. In classical mechanics you are saying that the free electrons are conducting the current and these free electrons are revolving around freely in that inside the atoms, right? But we are studied as that level, right now. But actually what will happen according to quantum mechanics means clouds of electrons is revolving around the nucleus, not a single electron. Clouds. If you are seeing the clouds, yes, it has bunch of clouds, right? Similarly, the electrons are revolving around as like clouds. And the last here, the one is relativity, that is invariance. Okay, with respect to time, we are going to relate the moving object or rest object with another frame or same frame. From that we are going to make the relation between one of the object is moving or rest or both of them moving, right? From that we are going to take about relativity.